Good evening everyone, welcome to One Concept Per Day portal. The concept that we are today discussing is about the Bohr's atom model, and we already seen one question as seen here. I just explained you about what is Bohr's atomic model. This was taken from the year 2003 May. The question was not tough indeed, but it was focused more on the theory part. So therefore, if you do such kinds of old kinds of papers, you will get to know more about the theory part. That's why I have taken this one. And thus you learn the concept first and then you apply to the next one. You also apply it at the same time. Okay. Now the next question that we are going to do now is about understanding this in a much more way, a clearer way. So this is taken from 2006 May, set 1, paper number 3, paper 3. Okay, it's not paper 2 because I can see there's an E5 here, so it corresponds to paper 3. Okay, so Niels Bohr developed a model, so we have learned all this. Okay, there the electron is going downward, here it is going upward. Doesn't matter, electron, let it go wherever you want. Okay, the speed v of an electron may be shown to be given by the expression v square equal to so much. You need not by heart it, right? So it's already given to you. Right. Identify the symbol epsilon naught in the above equation. What does the epsilon naught stand for? Epsilon naught stands for permittivity of free space, non-unity of free space. Okay, and if you want, you can also write down this value, which you get it from your data booklet. Okay, you can write this as 8.85 into 10 to the power of minus 12. You get this answer. Then state Bohr's assumption relating to angular momentum. Bohr's assumption. What is angular momentum? We already know that, right? We have seen this in the previous video. Also, if you do not understand, this one, you can go back to the previous one to get a detailed view of it. But for your sake, I'll just write down this value. I'll say the angular momentum. Okay, I'll write it down fully. I'll write down the angular momentum of an electron in an orbit, say nth orbit is quantized and is equal to n times h by 2 pi. Okay, this is known as the Bohr's assumption relating to angular momentum. And see, there are 2 marks given over here. Just don't stop over here. And such orbits are stable orbits, and the electrons do not radiate energy while orbiting. Okay, why does this come out? It's because of the electromagnetic theory that was contradicting it. So he introduced this principle. If you want to have a detailed video on it, you can go to my first video and observe what does it mean. Okay, next. Using this assumption to deduce that the radius r is given by so much wherein is a positive integer. So you need to use this equation and you need to use this equation to deduce this equation. Or if you want, I can just write it down. You need to use mvrn is equal to nh by 2 pi. This is the first thing that you are going to use. And you are also going to use v square equal to e square by 4 pi epsilon naught rm. I'll write down that also. V square equal to e square divided by 4 pi epsilon naught. What is that? I forgot what is that? Rm. Rm. Let me write R. I'll put this n over here. It's confusing. Rm over. In fact, if I use this one here, I should put n also here. Since you are not using this, so I'll just remove here. Okay, I'll write like this. R into here. Okay, we have to use these two to get an expression for R. So what should I do? See, what does this? See, in such kinds of questions, first thing, because you know you're deriving it for the first time. Okay, this definitely is an HL question, not for an SL1. So now you see, this has n, this is h, this has epsilon naught from here. Pi it has, m it has, e square also here it has. What it does not have? It does not have this value of v. Which means what? You need to eliminate the value of v. Simple. So what should I do? Eliminate the value of v. So how do I eliminate? Take this value of v. Take this as a subject. Now I can now write v is equal to nh divided by 2 pi m r. Okay, from here. I take this value and substitute it here. When I do this, what will happen? I will have n square h square divided by 4 pi square m square r square. Whole thing I am just squaring this. It should now be equal to e square divided by 4 pi square, sorry, 4 pi epsilon naught r m. I'm just writing this equation as such. Okay, got this? So you just squared this one, put it over here, and this one I'm just going to retain like this. Now I can cancel whatever I don't want, whatever is common between them. 4 I can cancel. There's a square here, this pi goes away. Then this m, this square goes away here. This is r square goes away here. Now let us rewrite this once again. I'll write this as n square h square divided by what is remaining here. Square goes away, you have a pi here. You have a pi here. Then m is available here. Then there is an r here. Is equal to, now I have an e square divided by 4 pi goes away, you have an epsilon naught. Rm is not there. What do I need? I want r to be proved. I want this r outside, everything on the left hand side, right hand side, right? So where is this r? R is here. So what I will do is I'll pull this r this side and push everything to the other side. Okay, so what I will do, I will take a cross multiply n square h square epsilon naught is equal to pi m r e square. I have written like this. Now what do we need? I need the value of r. I'll do one thing. So I will take, I'll rewrite it in the left hand side to right hand, which will be more easy for you to understand. Pi m r e square. I'm just rewriting the same thing. It should be n square h square epsilon naught. When I do this, now what do we do? Now I want only r here. R should now be equal to epsilon naught n square h square. I just taken epsilon naught here. Okay, nothing great. I'm just writing it. Divided by pi m e square. Pi m e square. This is the final expression. Let us see, have we arrived at it? We have epsilon naught h square. Okay, I'll write it like this only. I'll write epsilon naught h square divided by pi m e square into n square. R is equal to, see, have I arrived at the epsilon naught n square divided by h square divided by pi m e square into n square. Epsilon naught h square divided by pi m e square into n square. So got this, right? So such kinds of questions, derivation part is not very difficult. Okay, and especially in IB, it should be very easy because most of the information is already given to you. So you just need to look into it, plug in and get the answer. Okay, this is completely an HL part question. Then use the expression in B2 to calculate for n equal to 1 a numerical value for r. Comment on your answer. So what you need to do is use this expression here, put n equal to 1 and get the answer. Okay, so towards it, I will take the expression r is equal to epsilon naught h square divided by pi m e square into n square, and I put n equal to 1. When I put n equal to 1, I'll put r1 here, which should be epsilon naught h square divided by pi m e square. Let us see whether our equation is correct. Epsilon naught h square by pi m e square. Everything is right. Now what I need to do? Substitute all the values. Now how do you substitute? The values of all these are given in your data booklet. You need not worry. You can use your calculator to do it. Let me write it down, then you can use your calculator. R1 is equal to 8.85 into 10 to the power of minus 12 multiplied by 6.63 into 10 to the power of minus 34 the whole square, okay, divided by pi 3.14 multiplied by m. What is m? Mass of an electron. 9.1 into 10 to the power of minus 31 multiplied by e. What is e? 1.6 into 10 to the power of minus 19 the whole square. Okay, now what I will do is I'll use my calculator to get all these values correctly. Okay, so this value, put it here. I have 8.85 multiplied by 6.63 multiplied by 6.60 twice is equal to so much, divided by 3.14. I got 123.89 divided by 9.1. I got 13.61. Again divided by 1.6 square. Divided by 1.6. I get this value divided by 1.6. 5.32 I get, right? Let me write down 5.32. What have I done here? I have not used any powers. Let me use my power save. So this should be 10 power minus 12. This 10 power minus 34 whole square should be 10 power minus 68. Minus 68, very big power. And here it is 10 power minus 31. When it comes upwards, it becomes 10 power plus 31. And minus 19 whole square is minus 38. When it comes upwards, it will be plus 38. Okay. Now let me write it down as 5.32 into 10 to the power of, here I have minus 68. Okay, let us write, let me use my calculator for the sake. So now what do I have here? I have 31 plus 38 minus 68 minus 12. Okay, so this is minus 11. 10 power minus 11. Unit is meter. R is meter, so I have converted everything into meter. I need not worry. So everything into SI units, so this will be in meters. So this I can now write this as 0.53 into 10 to the power of minus 10 meter, which is equal to 0.53 angstroms. 10 power minus 10 meters angstroms. Now he has asked about, so to calculate for a numerical value for R, you have got this value. Comment on your answer. The whole thing here will give you 2 marks. When you say comment on your answer, what will you write? You need to comment on what is this. This is nothing but the distance. We can now write distance between the nucleus and the electron in the first orbit of the hydrogen atom is equal to 0.53 angstroms. Hey, how do I know so much? Okay, if you ask this question, how do I know to write so much? Now let me go back to this. See, there is a diagram given here. Okay. Why is this diagram given here? There is also something mentioned over here. The diagram given here suggests that there is a proton, there is one proton here, there is an electron. What kind of atom is it? Hydrogen atom. It is already mentioned. So hydrogen atom, n equal to 1, which means what? The nearest electron, okay, to the proton, to the nucleus. So this is the hydrogen atom, first orbit hydrogen atom, first orbit electron in a hydrogen atom, and this distance we are estimated to be 0.53 angstrom. Okay. So sometimes this radius is also called, this is the radius, right? This radius is also called as Bohr's radius. If you know this, you can write this. Otherwise, no issues, you can just stop it over. This will fetch you complete 3 marks. Okay. State one reason why the Bohr's model can be applied successfully only to hydrogen-like atoms. Okay. So what is the reason for why you can apply Bohr's model only to hydrogen-like atoms? Now, what's happening in a hydrogen atom? Now, you see, how did we start with this? So you had a nucleus. You had an electron. The electron was going around the nucleus like this over here. We assume this was R. The radius of the orbit was R. Now, when something is rotating like this, what do? We can write mv square divided by R is equal to kq square divided by R square. I can write this as a charge E and this as a charge minus E. Let me consider only the magnitude. So this becomes ke square divided by R square. So this goes away over here, and thus you can get an expression for V square. V square is equal to ke square divided by mr. Or this should now be equal to, what is k? K is 1 by 4 pi epsilon naught. This should be equal to V square divided by 4 pi epsilon naught mr. This you would have already learnt in your classes. Now, if you want to know, you can see this expression matches with what is given here. V square divided by 4 pi epsilon naught Rm is given. V square equal to, see here also, you get V square equal to E square divided by 4 pi epsilon naught mr over here. Let me assume there is one more electron here. Okay, it's a 2 electron atom. Let me assume something like this. If I have one more electron, then what will happen is there will be a force acting due to this electron. Okay, and there will also be a force acting on this electron due to this nucleus. But in addition to this, there will also be a force acting on this electron. Okay, this electron is being pushed away like this over here, right? So therefore, this one electron that you had taken over here, you assume that this electron has a driving force which is ke square by r square. Okay, you assume that a particle, an electron, moves in a circular path due to only one force. What is that force acting? It is nothing but k q1 q2 divided by r square. So you assume like this over here. But when I put one more electron here, then there is a force acting on this electron, which are two forces. One force is acting like this, and there is one more force which is acting. Let me write it down here. I'll write K into E into minus E. Minus E is minus K E square divided by R square. This is one force due to nucleus. Plus, there's one more force acting due to this. Let us say this distance is something like R2. Okay, this is R1 and this is R2. In that case, I can now say there is one more force acting here, minus E into minus E, which is plus E square plus K E square divided by R square. Once again, R2 square over here. R2 can be different. R2 can be equal to R1. R2 can be twice of R1 if they are opposite, diametrically opposite over here. Okay, so therefore, the net force will not be equal to mv square by r. So it will not move in a circular path. It can change. Okay, or the orbit of it can change. So our assumptions won't go wrong over here. This is one way of writing it. Okay, so how do you write? I have just explained. You have to write something here, right? So how do you write? You have to write additional electrons. Additional electrons gives a resultant force acting on each electron not equal to E square divided by 4 pi epsilon naught R0, where R0 is equal to 0.53 angstroms. You can write like this, or maybe you can say R0 is the radius of the electron's orbit. Okay, so it can differ. There's one more reason which you can say. You can say that the electrons shield the nucleus, and hence the atom, one electron, not electrons, one electron shields the nucleus, and hence the atom is electrically neutral. What do I mean by that? It means that if I have two electrons over here, then what happens is you can say this has a positive charge and this has a -2 negative charge. What's the total charge on the atom over here? The total charge on the atom is going to be a negative value, which is going to be an ion. We are not discussing ions over here. We are discussing only about an atom over here, a neutral atom. So you can mention this also here. Okay. Now, yes, this is the end of the problem. So I hope you would have understood the Bohr's model, how to apply Bohr's model, and how to do the calculations. Okay, based on this. So this will come to an end. And if you like this video, do share and subscribe to my channel for more updates. In the vacation, for those who are studying in IB1, I will be starting a new course that is on IA, the technical details that you require for understanding IA, okay, or to coin a problem related to your internal assessment and extended essays. Okay, so do join, and this will be especially for those who have subscribed to my channel, because all the material related to it will be into a separate channel, and those who subscribe to this will definitely get it. Of course, I'm planning to keep it as a free for this year. Let us see how does it go. More number of subscribers come, then definitely, and I can make it more free, and how it goes. Okay, thank you everyone.